Hello, and I'd like to thank everyone for taking time out of their very busy schedules to sit down with me for a bit to talk about virtualization technology. I've been around the world of virtualization since the late 1970s. Shows you how long virtualization has been in use. And so I've been watching it very closely, and in my role as an independent analyst and author, I often comment on events of the day. So let's look at these slides and see if we can discuss when is virtual machine software the wrong choice. So if we look what I'm planning to address today, I'm going to address what is virtualization, comment on how long virtualization technology has been in use and where, present a model, a thought model of virtualization that is very useful in discussions of different virtualization technology and when different virtualization technology should be used. I'm going to dive a little bit deeper into the thought of processing virtualization, then address when is virtual machine software the right choice, and maybe suggest in the next slide another type of virtualization technology that may actually be a better choice in some circumstances. Cover when is it the wrong choice, and then offer some suggestions of material people need to know before they embark on a journey to a virtualized environment. So what is virtualization anyway? This is a subject of a great deal of discussion, not really debate, but in simplest form, it's taking advantage of excess machine capability, that is, excess processing, memory, storage, networking, or some other resource to create an artificial or virtual environment for a function. And this artificial environment offers some advantages for that function and might be thought of as an attempt to create an ideal environment for that function that may be very different than the physical function or the physical environment that is really supporting that. So in some uses of virtualization technology, it is possible to make an obsolete tape drive, for example, appear to be part of the machine configuration, even though it is no longer available, no one sells it, no one supports it, but applications may still need to use that. And so virtualization technology may gather up all of the input and output commands for that device and convert them to work on some other device that is actually available today. That's one example of a virtual environment. Let's look a little bit more into the concept. Virtualization has been in use for a very long time. The first instances of virtualization, that is, to attempt to virtualize input and output, storage, processing capability, appeared on mainframes from Burroughs and from IBM and Honeywell RCA in the 1960s. In fact, that technology has become so established that I'm not even sure it is possible to run a mainframe application directly on the hardware. Everything is a virtual process in the mainframe world. Single vendor mid-range systems, and I'm referring to machines that used to be called mini computers, but evolved to be called mid-range systems. Typically they run either Unix or a single vendor operating system. IBM, for example, has their IBM I environment, which used to be OS 400 and OS 34, and I find them fascinating because they keep changing the name of the product, which certainly confuses me. But virtualization of various types was introduced in that environment sometime between the 1970s and the 1980s, depending upon the supplier. It started to appear in the industry standard systems market, that is x86 class machines, in the 1990s. So it's certainly been in use for a long time. One of the more challenging aspects of virtualization is that one or two suppliers grabbed a word or a phrase that has been in use in the industry since the 1960s and superimposed a different meaning on top of it, a meaning that tended to serve their needs and tended to obscure the fact that virtualization was something that was in use all over the planet. And this has caused a great deal of confusion and part of the reason for this presentation. If we look at the layers of virtualization, and I know that this is somewhat of an eye chart, but I will run you through it, and the book Virtualization: A Manager's Guide goes into each layer in some detail. If we look starting at the top, there's access virtualization, which is designed to allow two systems to communicate with each other without either having much idea about the characteristics of the other. An example would be being able to run a mainframe application from your iPad, and the mainframe application thinks it's talking to one of its own terminals, and the iPad thinks it's talking to a website. Application virtualization is a way to encapsulate an application so it can continue to run in an environment it was not designed for. An example would be, let's take a Windows XP application, encapsulate it, and make it run on Windows 7. Well, the application sees a Windows XP environment that it was used to, and Windows 7 may see a Windows 7 application, even though normally it would not have been compatible. Other uses of application virtualization on the client is to allow applications to be encapsulated and delivered to a machine piecemeal over the network. And with Windows applications, usually if 10 to 15% of the application code is delivered down to the remote system, the application is able to start up and start processing, and then the rest of the application can be delivered down the network as needed. It also makes it possible for people to copy a virtualized application as if it was a file and not have to go through the complete installation process. Back on the server, application virtualization has some other interesting characteristics, that virtualized applications may have a capability to run in parallel across a number of machines. And a workload manager component of the virtualized environment will accept workload requests and deliver it to different machines based upon how busy those machines are. Processing virtualization is the attempt to separate what people are doing from the underlying operating system and hardware. And there are a whole range of things that happen there, and I will talk about that in the next slide. Storage virtualization does for storage what access virtualization is doing for access. And that is the processing systems who are working with storage have no idea where the storage is, what are the physical characteristics of the storage device, and that allows a number of optimizations to be done to improve the overall performance, reliability, and availability of storage. An example might be that behind the scenes, data is spread out over a number of different storage technologies. Very rapidly accessing certain types of information may cause that information to be moved into solid-state DRAM-based storage, so it works very much like having an extension to the computer's own memory. Other less used data may be put in solid-state disks, so-called flash disks. Still, other data may end up on rotating media of different performance characteristics. And the storage virtualization capability would make all of that look like a single storage resource, and applications need not necessarily be re-architected or changed just because the media behind the scenes changed. Network virtualization does something similar for networking. A client and the server may think that they're the only thing on what is really a very busy network. They only see one another, they only can communicate with one another, and the rest of the network activities are not visible to them. And then, of course, if you look at the two sidebars, there is management of this entire environment that has to touch every layer, and there's security for that environment, which touches every layer. This is a really useful tool to think about virtualization technology and where it can be used. If we look a little bit more deeply into that processing virtualization layer, there are 5 different types of processing virtualization. And if we think about it for a moment, basically there's an attempt to, it's almost a spectrum of use, ranging from making many machines appear to be a single resource for some purposes, and the other end of the spectrum is how do you take one machine and make it appear to be many for some other purposes. But the 5 types are parallel processing monitors that allow an application or its data to be spread over multiple computing systems to achieve the highest possible performance. Workload monitors allow the same application to be distributed over a number of machines, and as work comes in over the network, the workload monitor delivers the work to the machine that has the most available capacity. This improves performance and scalability. Clustering monitors allow multiple machines to act as a single computing resource, and if it's a single system image cluster, it looks very much like a single computer, even though it may have thousands of computers underneath that are actually doing the work. You log into it, you work with it, you print, but you have no idea which machine is doing the printing. You submit batch jobs, and you have no idea which machine is doing the computational work. And then there are 2 that are focused on how do you make one machine appear to be many. One is virtual machine software that most people think is the totality of virtualization. And then there's another related but different technology called operating system virtualization and partitioning. Let's look a little bit deeper. When is virtual machine software the right choice? Well, typically virtual machine software is used to achieve 1 or 2 goals. The first goal is some sort of workload consolidation, and the idea there is to move workloads off of a number of older, lower power computers onto a single or small number of much faster current technology machines. The goal is to decrease hardware and hardware service costs. This approach has a lot of benefits because an entire workload, and that includes the operating system, the application framework, the database manager, all application code can be encapsulated either into a virtual server or a virtual client. And then that workload can be moved around the network as needed, or share a single machine with a large number of other workloads. An important point to consider here is that just because a workload is encapsulated does not mean that it is any easier to manage, nor does it necessarily mean that there will be a reduction in software-related costs. There may actually be an increase in the administrative costs to run all of those different operating systems and workloads on the same physical machine. It also may require some new expertise being made available to the organization. Not only will they have to have expertise in the operating system, the application framework, the database system, the application itself, the networking, they may also now have to have people who specialize in dealing with virtual machine software and how that works. There is another goal that requires one other element be added, but virtual machine software is often at the heart of a workload optimization or automation environment. And this is where individual virtual machines may be moved from machine to machine during the time that they're executing to make the most optimal use of the hardware resources that are available. As kind of a secondary effect, when the virtual machines are moved, it may also be to deal with an outage that is developing. But since it's necessary to move a complete workload, that is all of the related software, this may not be and is usually not the best way to achieve a highly available, highly reliable environment. There's another type of virtualization technology, as I mentioned before, operating system virtualization and partitioning, that may be used for those same things. The key difference is virtual machine software encapsulates a complete environment that includes the operating system and all software that's layered on top of it. Operating system virtualization and partitioning does a very similar thing, but there is only one operating system in use. It just partitions the use of that operating system so each workload sees a system set up just for it. and it has no idea that there are other partitions running, that the system has different networking devices, different storage devices that it may not have access to. This is a better choice if you're running workloads that are all the same operating system. So if you're running a bunch of Windows or a bunch of Linux or a bunch of Unix workloads on the same machine, operating system virtualization and partitioning may be a much better choice. You still get the isolation, you still get the reduction in number of systems necessary to support this, but it uses far less memory and storage, and switching from workload to workload is much, much quicker because it's very much like switching from one process to another on an operating system. Now, different vendors call this capability different things. IBM likes to call these LPARs, or logical partitions, on one family machines. They call it VPARs on another. Many of the Unix suppliers use the term containers. But the idea is the same across all of these, and that is you keep one operating system and you put multiple workloads under it. And many times, if what you're doing is running multiple Windows instances on a single machine, it actually may be much less costly because in this environment you have one operating system license. If, for example, you were looking at an environment that had 40 virtual machines running, if you were using virtual machine software, the company had to pay for 40 operating system licenses if you were using, and also have the memory and disk storage that would support 40 operating systems. In an operating system virtualization and partitioning environment, you may only have requirement for a single operating system, a single license, and that could be a significant cost reduction. Now, when is virtual machine software just the wrong choice? Well, the simplest answer is when another form of virtualization would have been better. So if access virtualization was really the goal, that is, you wanted to make multiple machines be able to communicate with one another without having either side need to know what the other system is, then access virtualization would have been a much better choice. When application virtualization is needed, it may be easier to use an application virtualization product rather than virtualizing the entire environment. And that, if the goal was to make one version of the operating system coexist with another version of the same operating system, it might be much easier to use an application virtualization product rather than using virtual machine technology. And if we think about other ways that processing virtualization is utilized, virtual machine software may not be the right choice. So, for example, if we're looking at geophysical processing or we're looking at architectural modeling, these are very, very processing-intensive applications. Inserting workloads into virtual machines would mean that the machines would be spending at least part of their time running the virtual machine manager and not doing the work that is necessary. Those people would probably be much better served by using some parallel processing software. Or if the goal is raw scalability, I mean, you could put each instance of a workload in multiple virtual machines on the same system, but I don't believe that that would perform as well as spreading those workloads over multiple machines and using a workload manager to distribute the work among them. If you're looking for reliability, availability, disaster recovery, some kind of clustering monitor would probably work much better than using virtual machine software combined with virtual machine migration technology. So some suggestions, and I realize these will be somewhat vague, but the point is you really need to know what's going on before and what the requirements are before making a selection of virtualization technology. Unfortunately, a lot of people have a tendency to pick a technology they know and try and force fit it, try and make it do whatever it is that's needed. I've heard it said that when you hand a child a hammer, everything looks like a nail, and things that maybe a wrench would have been better for get hit with the hammer. So it's really important to take some time to understand what applications and workloads are in the environment, and then know what are the requirements for performance, reliability, availability, scalability, management. All of those things need to be well understood. It's also really important to know which organization within the company manages those things. Many organizations have completely separate divisions that look at the network, look at the facilities, look at the power, look at the cooling, look at the servers, look at the database. And it's really important to understand how all of those groups need to work together, or you may have procedural and process problems when you put them all together on a single machine. Then it's possible to look at what is the proper tool for the task at hand, rather than whatever the tool du jour is. And I really like something that Lawrence Peter is attributed to have said: if you don't know where you're going, you're likely to end up somewhere else. So these are the topics that are presented in Virtualization, a Management Guide. And now I would love to open it up to questions that are posted in the system.
Hi, Dan. We do have one question that just came in, and folks, we'd like to let you know, please put your questions in the group chat. It's that little kind of reddish-colored icon towards the bottom of your widget tray. If you open that, you can type in your question for what you've been hearing Dan talk about today, and we can have him answer it while he's still with us. So in the Q&A tab right now, Dan, there is one question, and we're getting a couple more that's coming in.
Well, let me address the first question then while others have the opportunity to type in theirs. And the question was, what's the best virtual machine software to use to run Linux? And that is a question that I hate to be somewhat flip, but I will anyway. That's a question that is basically, how long is a piece of string? And the analyst would say, show me the string, I'll measure it, and then I'll tell you how long it is. Each one of the virtual machine managers that are available today, and the most common choices are VMware's product, ESX Server, Microsoft's product, Hyper-V, Citrix product called Zen Server, and there's a whole open source community behind the Zen virtual machine technology. And there's a relative newcomer called Kernel Virtualization, KVM, that is the darling of the Red Hat people right now. And KVM has also attracted a rather large and rapidly growing community called the Open Virtualization Alliance, or OVA. Each one of these has merits, and the question really has to be asked not just which is the best to run Linux, because all of them will run Linux in a virtual machine. The question is which will fit better in the management environment, which will fit best in the environment the organization has. So, for example, if the company has a very good a purchasing agreement with VMware that they get a highly advantageous price, then even though technically KVM might be more efficient in the use of a machine for Linux, then maybe VMware was a better choice because it would reduce the overall cost, and also that the people in the environment would probably know how to manage it. The same would be true if you had a largely Microsoft environment. Maybe Hyper-V would be a better choice. So I can't give an easy answer other than to say you really have to examine the environment and determine which of these products fits best. And this also addresses a number of the other questions that I've seen in the Q&A section, which is the best supplier. And the truth is each of them has merit. Each of them is working very hard to create a powerful, manageable, secure environment that would allow multiple workloads to run simultaneously on the same machine. Most of them have also worked very hard to make it possible for a virtual machine to migrate from one physical machine to another to best optimize the use of the environment or to deal with outages or failures. And so it's really hard to pick one that is best because it really depends upon the needs of an organization. And some organizations will find that VMware is the best choice for them, and others would say that's the worst choice because of its pricing, its terms and conditions. Maybe they would select some other product. But there is no best single choice. It is true that VMware has the lion's share of the market, but we are seeing some pretty interesting gains from the other suppliers. Question that I have here is what sort of virtualization is going on in cloud installations? And that is another question that is quite interesting because it depends on which type of cloud you're referring to. If we talk to people who focus on cloud computing infrastructure, and I happen to be one of those people, there is software as a service, and that's where people are accessing a complete application environment that is running somewhere across the network. Well, that may not even be a virtualized environment except for virtual access. There's also platform as a service where people are given a set of development tools and application frameworks, but they develop applications and run them on somebody else's data center, paying for it as they use it. And that may be using application virtualization, but no other type of application. No other type of virtualization. And then you have infrastructure as a service where people may be buying access either to a physical or virtual machine, using it as they need it, releasing it when they don't need it, and paying for it as they use it. So once again, it's not a simple answer, but it depends on what type of cloud you are looking at, whether or not virtualization technology in the form of virtual machine software is even being utilized. Now, I have a question to go over storage virtualization, and let me address that again. Storage virtualization basically is technology that gets in between the system doing the processing. And in today's environment, that probably means a whole series of systems, one that processes the user interface, one that processes the application logic, one that processes the database, and one that may process the storage. But the goal is that all of those machines are talking to storage without knowing where it is, without knowing the physical characteristics of it. They may even be presented the view that they are talking to one very huge, extremely reliable storage device, when in reality, on the other side of the storage server, it may be hundreds or perhaps thousands of storage volumes. But the idea is it allows you to insert some level of intelligence into the storage subsystem so that you can reduce the overall storage being utilized. So, for example, if it was possible to recognize that certain data is stored over and over and over again, wouldn't it be nice if you could store it once and then point to that one storage location regardless of who asked for it? That's called storage deduplication. You may also want to compress the storage so that it takes a smaller amount of physical space, regardless of whether you're storing multiple copies of the same thing. Or you may be using many different storage media all in the same storage system. So, for example, a very intelligent storage server might have cache memory that is being used like a disk, so that is actual machine memory. It may be having flash drives that are fast being used for another type of storage. It may have very high speed, very expensive rotating disks for another type of storage. And it may have slower speed, less costly disks for still another type of storage. And it may actually move data to tapes or optical media for long-term storage that has the lowest cost per megabyte of storage, but performs fairly slowly. There are storage virtualization products that do that automatic tiering process and will actually move storage around to optimize the use over time. So things that are rapidly accessed move to the highest speed memory subsystem. Things that are accessed only occasionally but are large, they may be moved out to tape or optical. So I think I've kind of addressed those questions. Are there any other questions?
Actually, Dan, yes, a couple more have come in. There's a refresh button just right above the Q&A tab towards the right. If you click on that, let's see if you can get the new ones that came in.
I have seen them. Thank you.
Okay.
This was obviously pilot error. So I'll raise my hand and say I didn't hit the refresh button. If I look at the top question on the list, VMware introduced a phone operating system virtualizer. And the question was, is it going to be a fad or is it going to be something of importance? And I'd like to point out that VMware was not the first, nor is it the only virtual machine software supplier that is designed to sit on handheld, mobile, or battery-powered devices. It acquired a company that did that and then started talking about that. There are many others that are doing that. But the idea is that if you look, for example, inside of a mobile phone, there are often several computers. There's one called a digital signal processor that allows the analog voice to be converted to a digital signal and sent out over the radio network. There's another type of processor that displays the user interface and runs the applications that are seen on the screen of a smartphone. There are suppliers that are saying, why should you pay to have two entirely different processors in the same phone? That consumes memory, it consumes power, it makes the devices more expensive. So wouldn't it be smarter to have one higher speed microprocessor do both of those functions? And there are suppliers who have created software designed for that very purpose. And so by having a virtual machine technology inside of that, the applications that were written for earlier generations of smartphones may be able to run in a partition and think they're running on the same processor they were used to running on. And the digital signal processing functions that make the phone work as a telephone may run in a different partition, and those applications may think they're running on a microprocessor that they are used to, and yet really both of them are running on a newer generation processor that is much faster and has enough capacity to do both functions. Is that going to be the future of smart handheld devices? I think if we look at the drive to reduce overall cost of the devices, while at the same time increasing the number of functions and at the same time increasing the battery life of these systems, it seems like the only reasonable way to address this at this point is to use really fast processors and some intelligence in how we run the different workloads. And that sounds like a job for virtual machine technology. Is that going to be the way everybody does it? I don't think I have enough information to say yes or no to that. But it certainly would address a number of the more thorny issues that people face right now in terms of processing wonderful applications, making sure that the battery life is very long. So I think we're going to have to watch that. I don't think it's a fad, but I don't think that all suppliers are going to immediately jump on that and say that is the way we need to do things. Now, we have another question that talks about big data analytics and references a specific big data tool called Hadoop. There are a couple of other tools from third parties. I think this whole concept of big data, where we are using several types of virtualization to spread data over a number of physical machines so that it is possible to look at and process data at speeds that are so high that rotating media simply cannot keep up. So, for example, if we were doing some kind of real-time monitoring of an online game where there may be millions of people playing the game, and as one person touches a piece of data, almost before they get away, someone else has touched the same piece of data. You would never be able to get that back to rotating media fast enough for the game to play well. So one of the things people have used is trying to find ways to virtualize the memory and share memory across multiple machines in some structured way, and then make it possible for applications to look at that structured memory as if it was storage, when really it's memory inside of a computer. This is being used in a number of ways. One of them is to analyze huge amounts of retail data in real time. So a company like, say, Dollar General, I actually wrote about Dollar General in a customer profile piece on my column on zdnet.com not too long ago. They have multiple billions of records of transactions online all the time. And so their suppliers can look, when has their product sold, what has it been sold with, what time of day has it been sold, and they can start to look at and make real business decisions about the supply, the product, that's based upon real information instead of a seat of a pants guess, or based upon information that's months and months old. We're also seeing big data type of applications used for people analyzing geophysical data, pharmaceutical research data, and quite a number of other things. Financial services has been very interested in this as well. Hadoop is one of the tools that is used, but there are several others. And I really don't have time to go into the strengths or weaknesses of each one of them. But it is a really interesting trend, and one of the things that I find so interesting is if you combine this idea with cloud computing, that is, people buy access to computing resources as they need them. They do some work, and then they let go of the resource, and they pay for only the resources they used. If we combine the thought of big data and the thought of cloud computing, smaller companies that may never have been able to afford the data centers for huge banks of computers to do the kinds of analysis the big companies do may find that they can now do the kinds of analysis that their bigger competitors do, and it levels the playing field and makes it possible for big companies and small companies to go at the market in a data-driven, knowledge-based approach instead of, well, this is the data we have at the moment. I think that was kind of a long-winded answer to a simple question, wasn't it? So let me look at what other questions we have that have appeared. Now, the next question is, do all VMs provide for operating system virtualization, or is that a separate product? And truly, it is an entirely separate technology. A virtual machine manager basically sits between the operating system and the underlying hardware. There's another approach where you have a general-purpose operating system that has a type of virtual machine manager built into it. And then it allows guest operating systems to run underneath that operating system. But that whole approach assumes that you want to encapsulate the entire virtual server or virtual desktop environment. The operating system virtualization is a function that's built into certain operating systems or added on later. So, for example, Windows does not have a virtual machine operating system virtualization and partitioning capability. A third party called Parallels has a product cleverly called Containers that adds that container capability. Operating systems like Unix and Linux have that built in, although sometimes the suppliers will charge you extra to use that. But the idea is that operating system virtualization works best when all of the workloads are running under the same operating system. And virtual machine managers are better when you have a mix of things, or you need to encapsulate the entire environment. And I think I've addressed all of the questions that have come up so far.